If it falls down, hopefully one of you has spider instincts to turn around and catch it before it falls down, all right? Move forward. We're done with the revision. We're now moving forward with principles of flight. What we spoke about is air characteristics, 71% or 70. How many percentage of nitrogen? 70? 78% nitrogen, 21% oxygen, and 1% of the rest of the gases. We spoke about how the air is the most densest at the lowest level. Air density reduces when you go higher. Air temperature reduces when you go higher. And what else reduces when you go higher? Air density, air pressure, and air temperature. All three reduces when you go higher. Everybody okay with that? Right? Now, we're now talking about different air speeds. There are different air speeds. Indicated airspeed, IAS, is the first one. The indicated airspeed is whatever your indicator shows you. If your aircraft has a first instrument, IAS, which is the indicated airspeed indicator, right? You read out 60 knots, 60 knots. That is your indicated airspeed without calculating or calibrating. The next one is the CAS, calibrated airspeed. The word calibrated means you're calibrating something. You know, you're calibrating your joystick, you're calibrating your game devices, right? Similarly, imagine that there is a mechanical error. There is a problem with your airspeed indicator, so you have to mechanically fix the error. And that will give you the calibrated airspeed. Where can I find the method of calibrating? Your pilot operating handbook, POH. Please write it down. Every aircraft has a POH, pilot operating handbook. These pilot operating handbooks will tell you exactly what needs to be done to calibrate your devices. That's the equivalent of me standing on a weighing scale and it says a certain weight, 85 kgs. Oh man, I get down from it and it still says 2 kgs. What just happened? It's not calibrated right. It's not calibrated to 0. So when I stand and if it says 85, I'm actually 83. I wish I was 83. I've gained a lot of weight. I used to be 83 once upon a time last year. I do blame Hyderabad food. I have reduced a little bit in the last 1 month of Ramadan, obviously. Pilot operating handbook, definitely Hyderabad. The last 1 year, I came to Hyderabad every month for a 3-4 day visit. And this time I've only had like 1 or 2 greasy Hyderabadi amazing food. Halim was amazing. I couldn't have missed Halim, right? Anyway, so that's calibration. Similarly, I have to calibrate my airspeed indicator. That new calibrated speed is the second one, calibrated airspeed. After taking the indicated airspeed and fixing plus, minus, 1, 2, whatever according to the pilot operating handbook, I now have a more accurate speed. I got rid of the mechanical error, the instrument error, the position error. These are different errors in your airspeed indicator. You get rid of those errors by calculating it, you get your calibrated airspeed. Next, what you do is, you now have to worry about something else. Calibrated airspeed is not good enough. You have to calculate your true airspeed. So these airspeeds are all fake airspeeds, right? Your true airspeed, you have to imagine that the air is at 15 degrees Celsius, 1013.2, density 1.225. If it was according to the ISA, then you don't have to worry about any add or subtract. But guess what? It will never be 15 degrees all the time. It will never be 1013.2 or 122.5 and all of the standard numbers. So because the temperature and pressure is non-standard, we have to add and subtract based on the temperature and pressure difference. So plus or minus, because of the non-standard temperature and pressure, when you get rid of those errors, that's when you get your true airspeed. So in a nutshell, I look at my airspeed indicator, it shows me a random number, 80 knots. That is my indicated airspeed. But I check the POH and I calibrate the device. Now it is the calibrated airspeed, CAS. That's not good enough. I have to worry about non-standard temperature and non-standard pressure because it's not going to be ISA all the time. Add or subtract. Now the airspeed, whatever I get, is called as true airspeed, TAS. But that's not it. That's not done. We're not done yet. There are some more errors called as compressibility error. You know, the pitot tube is a device which looks like this. It's normally on the left wing of the smaller single engine aircraft. The air goes inside the sensor, tiny little hole. The faster the air goes inside this, obviously the indicator will show you a bigger number. But if you're going more than 300 nautical miles per hour speed, the air going inside here at 300 nautical miles per hour gets compressed inside the pitot tube. Because it got compressed inside the pitot tube, guess what's going to happen? The air is going to create a compressibility error inside the pitot tube. Because of that error, your airspeed indicator is not going to show you a correct number. None of our small planes would ever have to worry about going faster than 300 knots. But if you're flying one of the faster jets, only then you worry about it. And in that case, again, you go back to your POH. It's your go-to book for everything, Pilot Operating Handbook of your aircraft. I am flying at 350 knots. What should I add or subtract for compressibility error? It will tell you a number. If you're between this speed and this speed, add +1, +2, -1, -2, whatever the number is. You do that, and that will give you the EAS, equivalent airspeed. Equivalent airspeed. I'll get to that one second. You're not done yet. You have some more airspeeds which you have to calculate. Now you have to worry about, is the air pushing me from the front or is the air pushing me from the back? If the air is pushing you from the back, tailwinds, it'll make you go faster. If the air is pushing you head on, headwind, that'll slow you down. If you have to add and subtract, if you have headwinds, you subtract. If you have tailwinds, you add. By doing that plus and minus, we finally get our GS, ground speed. Your ground speed is what's going to tell you how fast you're actually traveling over a piece of land and how fast you're going to cover the ground. Make sense? For navigation, to calculate the distance and to calculate how long I will need to reach a certain destination, I need my ground speed to cover how much ground I'm covering every hour. My airspeed indicator doesn't mean anything. I could be traveling very slow compared to the ground. I'm only covering very little bit of ground every minute, but there's a lot of headwind. So my indicated airspeed is going to show me a crazy high number because the air is pushing from the front. Does that make sense?
Crosswinds?
Different. There's a crosswind component. We'll get to that in a while. Yes, your question.
This video is only just physical? Is it a physical?
It's a physical book, but you have it on your iPad as well. Sure. You have your electronic flight bag, but back in my days, we used to have physical books we used to refer. These days, everything's online and PDFs. Everybody okay with that? So I want you all to be able to explain all the speeds. Quick recap, airspeeds. Starts with indicated airspeed, whatever you read directly as per the indicated instrument, indicated airspeed. You have to fix the mechanical error. That new speed is calibrated airspeed. You now have to fix the non-standard temperature and pressure, which is not as per the ISA. Now you get the true airspeed. Now you have to worry about, am I going more than 300 nautical mile per hour speed? Maybe not. If you are, add or subtract for compressibility error in the pitot tube, you get your equivalent airspeed EAS. And finally, add or subtract based on headwinds or tailwinds. That will give you your ground speed. Everybody okay with that? You'll have to explain this the same way I explained. Let's keep moving. Now, air has mass. So, what is the difference between mass and weight? Can you tell me what is the difference between mass and weight? Anyone? Please, Aditi, go ahead.
Mass is basically the gravity.
Mass is basically the gravity.
Pulling us,
No, that's weight.
Sorry, that's weight, right?
That's weight.
Yeah.
Weight is
the gravity
pulling you down. So your weight is different on moon compared to Earth because the gravity is less, right? So mass, your mass will be the same on moon, Jupiter, on Earth, or wherever you are. Or forget about going outside the Earth. Even if you're inside the Earth, your gravitational forces can change. If you're accelerating, you experience more G's. You're experiencing 2 G's in certain accelerations. If you're pitching up, you're experiencing positive G's. You're experiencing more gravity. You feel 200 kgs if you are feeling 2 G's, which is why you get stuck to the seat. You feel that sinking effect in the seat because you're physically not increasing your weight. Can you imagine, God forbid, in a minute, if your weight of the body instead of 70 is now 140, you've doubled your physical weight. Your arms, your hands, your brain will feel a pain because your body is now too heavy, which is why you feel the pain when you have high G's. Physically, you haven't added extra weight, but because the gravitational force is acting twice the time, you'll be in a pain if you go above a certain G. 5, 6, 7 G, it is deadly. After a point, it can kill you, but the point is not just your body, your entire aircraft. Your entire aircraft feels that extra weight. When you do a sharp turn, 60 degree, you're not feeling 1 G, you're feeling 2, 3, 4 Gs, depending on the aircraft, depending on the speed, right? So you'll actually feel that the plane is now acting heavy. Your engine suddenly your engine's like, what happened? It feels like you've just added extra pieces of rocks in your aircraft and your 1000 kg plane became 2000 kg. Your engine can't support that, right? That's why the plane starts dipping down, pitching down. So every time you realize, jumping on your Microsoft simulator here in our next door room, when you turn without changing the power, without pitching up, you will always notice that the nose will go down. Has to be. Because your engine is not creating enough thrust, your aircraft wings are not creating enough thrust to sustain the extra Gs. Back to the question, what's the difference between weight and mass? Mass is all of the mass, all the molecules and all of that inside your body, right? Weight is relative. So, which one is vector and which one is scalar? Who can tell me the answer?
Vector is the thing which has magnitude.
No. Weight and mass. Which one is vector? Which one is scalar?
Scalar is weight.
Scalar is weight. Are you sure?
Yeah.
No. Vector is weight because
Yeah.
weight has a direction,
Yeah,
right? So, everybody remember scalars and vectors? Scalar quantity, vector quantity, vector, whatever, right? So, scalar quantity is a quantity which is only a unit without a direction, a magnitude without a direction. But then we have vectors. Vector quantities are a magnitude and a direction. Weight is always acting towards the center of the earth. There is an arrow, there's a direction. Vector. Mass is just a mass, no direction involved. Velocity and speed. Who would tell me which one's vector and which one's scalar? Show me hands up in the air. Scalar quantity, vector quantity. I'm giving you examples. Speed and speed is? No.
Scalar.
Velocity is vector. Speed is only a magnitude.
No, isn't that scalar?
No,
Speed is scalar. Velocity is vector. Velocity is vector. Remember it that way. Velocity is a speed with a direction. So when I say I am flying 80 knots speed heading 320, vector, you're associating a direction. Force, most of the forces we talk about, a force has a direction. I am applying a certain force on this object. It is moving in a certain direction. Exactly in the same direction as the force applied. All the forces are vector quantities. Make sense? So these are some of the things you have to remember from your high school days. Yep. Any questions?